Hello everyone, I'm Shivachan. Today I'm going to explain the given topic of remote procedure called RPC implementation from the course of operating systems. I'm Shivachan. Let's start the presentation. Um, Introduction to RPC. Remote procedure called RPC allows programs to execute procedures on remote systems as if they are local. It simplifies network communication by abstracting the details of message passing. RPC is widely used in distributed systems to enable seamless interaction between different machines. So these RPC, the remote procedure call, allows to execute procedures uh, such as the remote systems if they as if they are local. Uh, so what this explains is basically to execute a call from a part if it's in a singular computer, it it just it calls the given function to execute the given procedure. But this RPC remote procedure call allows the programs to execute procedures on a remote system, like a different system which is separated from uh, the system which is the RPC is located. This RPC can be used to control the system remotely using from the system which contains this RPC and the access to the given remote system as if they are local, as if they are stored in a singular place or if they are a singular system. This simplifies network communication by abstracting the details of message passing. So how this works is by this simplifies the network communication, like the long distance execution, as if like it abstracts the detail, like it hides away or makes the uh, message passing details in the back end of the computer by using the process of abstraction. So this RPC is widely used in different distributed systems to enable seamless interaction between different machines. So this RPC is used in a variety of systems to operate many machines used remotely through a singular system, which is commonly seen in most of the days today, such as operating a printer via a computer in our home itself, or by operating a smart TV, smart fan, smart devices, etc. in home, which also pertains as a RPC itself. So coming to the basic concept of RPC. RPC involves a client that requests a service and a server that provides the service. The client calls a local stub that packages the request into a message sent over the network. The sender receives the message, the server receives the message, unpacks it, executes the corresponding procedure. So how this RPC works is by this involves a client between the given sender and receiver. So this given client requests a service from the receiver and a server which provides a service, like a client that requests a service and a server that provides a service. So this client sends a request to the server, which then the server provides the service itself. So the sender corresponds to the client and the receiver corresponds to the server. So the client calls a local stub that packages the request into a message sent to over the network. So the message is sent over the network. The server receives the message, unpacks it, and executes it of the like what is the given input that the client has given and how it pertains to execute the given message. The server receives the message and unpacks it and executes it according to the corresponding procedure provided by the client. And coming to components of RPC system, client side stub acts as a proxy for client procedure call. Server side stub handles incoming requests and invokes the appropriate server process. The RPC runtime system manages communication, data serialization, and error handling. So this client side stub acts as a proxy for a client procedure call. The server side stub handles incoming requests and invokes the appropriate server process. The RPC runtime system manages communication, data serialization, and error handling. So the client stubs, which we read about earlier, which helps in packaging the message, this acts as a proxy for client procedure call. So this side stub itself is the main component in the call itself. So the server side stub handles receiving the incoming crystals from the request from the client and then invokes the appropriate server process. This RPC runtime system manages communication, data serialization, and error handling. So due to this RPC, the runtime system which runs beyond the client and the server side stubs, in behind it manages the communication between client and server, the data serialization, how the data is handled itself, and the handling of errors, like the whatever the errors happen in this process of RPC. So the RPC properly works. The client calls a local procedure stub, which sends a request to the server. The request is serialized and transmitted over to the network to the server. The server processes the request, executes the procedure, and sends back the response. As I said earlier previously in the basic concept of RPC. And yeah, data serialization and marshalling. Data marshalling converts procedure parameters into transmittable format. Serialization ensures data structure compatibility between different systems. Proper marshalling is crucial for accurate data transfer and procedure execution. Data marshalling converts the procedure parameters into transmittable format. So the procedure parameters, like the basic rules and details of this data marshalling, it converts the procedural parameters into a transmittable, uh, a convertible format, which can be converted and sent into various uh, commands, etc. The serialization ensures data structure compatibility between different systems, even if there might be a difference in the uh, in the systems itself. This data serialization ensures that the data structure compatibility between two systems remains the same, even though the difference between the two systems itself, uh, which greatly increases the variety to use the RPC in different devices at a singular time. Even though they are of different platforms or different type of hardware itself. And proper marshalling is crucial for accurate data transfer and procedural execution. Without this, uh, like the process may not work, because uh, there may be different devices. Not every singular device is same. Many have different components which have certain exceptions in themselves. So how this is designed is to like correspond to every singular device, through which we can remotely operate them, even though if there are any type of differences between the two devices by itself. And yeah, synchronization and communication protocols. RPC can be synchronous, blocking the client until a response is released. Asynchronous RPC allows the client to continue processing while waiting for a reply. Protocols like TCP or IP are commonly used to ensure reliable message delivery. Yeah, this is a communication protocols, like uh, we can we can decide how the system works and how the communication protocols do work. And uh, but this enhance the proper message delivery, so we need to make sure these are properly executed. And coming to error handling in RPC systems incorporate timeout mechanisms to detect failed requests. Retries are often implemented to handle transient network errors. Proper error handling ensures robustness and reliability of remote procedure calls. So the RPC systems incorporate timeout mechanisms, uh, which detect the failed request. If the requests are out of time or not reached properly, this detects the failed request. Like the system detects the requests are not received and make sure that they are received properly. Retries are often implemented to handle transient network errors. So there are multiple retries being done simultaneously to handle these network errors. Proper error handling ensures robustness and reliability of remote procedure calls. The proper error handling makes sure that these RPCs or remote procedure calls are stable and are being executed from the remotely. Coming to the advantages of RPC implementation, simplifies the development of distributed applications by hiding network complexities, promotes modular programming through clear separation of client and server functions, enhances scalability by allowing distributed processing across multiple systems. So this RPC, the simplifies development of distributed applications. Like as I said before earlier, there may be multiple devices, but through RPC you can use them for singular device, such as in a smartphone devices. Like there are different appliances can be controlled with a singular mobile phone. By handling the network complexities between all of them, they may not be all different devices, but they can be controlled as a singular device through a unified OS. So which greatly enhances in usage of the devices. This promotes modular programming to clear separation of client and server functions. Uh, Through the simple separation of the client and server functions, the programming can be modular and can be multiple. Enhances scalability by allowing distributed processing across multiple systems. So this can be accessed to multiple systems, which makes it the biggest advantage that there is. And coming to challenges and limitations, network latency can impact RPC performance and responsiveness. Compatibility issues may arise due to differences in data formats. Security concerns such as authentication and data encryption require additional mechanisms. So yeah, the main problem in this is the network itself. The network is not currently stable. This will be greatly impacting negatively impact the RPC performance and responsiveness. Compatibility issues may occur sometime, most of the time, because they are not simply a unified system, and due to the differences between their hardware and software formats, this can be these limitations cannot be completely reduced, but can be uh, decreased to ensure a minimal compatibility to operate the basic functions but not the advanced ones itself. Security concerns, which are supposed to be normal, because this is operating at a very thin line, due to it having a connecting to multiple devices at once. The focusing of a single encryption, data encryption, and uh, the authentication will require uh, even more processes in itself, which may complex the entire RPC system by itself. So these concerns are existed. Then coming to the conclusion, future trends. RPC remains a foundational technology in distributed computing systems. Modern implementation incorporates security features and support for diverse protocols. So future developments focus on improving efficiency, scalability, and security in RPC mechanisms. This continues to be a going trend. It's a foundational subject, so that we may experience the improvement of it, and may see it commonly in our lives in the future. Thank you. Thank you for listening to the presentation.